And when your body's in a state of ketosis, that means that your metabolism has shifted away from glucose to fatty acid oxidation and ketone production and ketone metabolism, specifically in the brain and in the heart. I'm an advocate of the ketogenic diet for specific therapeutic applications. I actually follow the diet myself, or a modified version of the diet. It's not a fad diet. I study it as a valid medical therapy. I think of the ketogenic diet as like a prescription strength diet. We can all achieve ketosis, and there are many different ways to do that. And there are really profound therapeutic advantages to being in ketosis. It's kind of unnatural for humans not to be in a state of ketosis, given that our early ancestors had limited food availability, limited carbohydrate availability. The frequency of their meals were not anywhere near what the standard American has. And the body can use whatever fuels are available. And ketones are one of those fuels that should be available through limited fuel availability, which was a natural state that we have essentially silenced in our modern everyday life. The ketogenic diet is a very precise macronutrient ratio that produces a profound physiological shift in brain energy metabolism that has anti-seizure neuroprotective effects. I think there's maybe over 100 clinical trials now registered on clinicaltrials.gov, just looking at, if you just type in ketone supplement. And, 5 years ago, there was nothing.
Hey there, welcome to the Happy Habit Podcast. I'm Matthew. I'm here every week talking all things health, well-being and self-improvement. If you get any benefit from this episode or from any of the previous episodes, show your support. It is free. You can like, subscribe, join the other 2,500 plus subscribers that I've managed to accumulate over the last 9 months on YouTube. And if you'd like to, you can share, tell other people about this podcast series so they can get some benefit and value from it too. Now, today I speak with renowned researcher and Professor Dominic D'Agostino about the benefits of the ketogenic diet for those looking to manage their weight, but also we explore the therapeutic ketogenic approach used to treat diseases such as cancer and epilepsy. We hear the production of ketones is actually something that our bodies have always engaged in, not just since the invention of the ketogenic diet. We talk about macronutrient ratios and supplementation, and we discuss fat intake and its impact on our biomarkers. We also talk about the biomarkers we should be asking our doctors to check on our behalf. Dr. D'Agostino is one of the most highly respected voices in biochemistry and neuroscience. Expect to learn a lot from someone who engages in the ketogenic diet and lifestyle himself. Central to the ketogenic diet, which I know you're a proponent of, is implied in the name, essentially keto, which refers to the production of ketones. Can we define what ketones are and why are they significant from a metabolic dysfunction standpoint?
The ketogenic diet, that's right, it's the only diet that's defined by an objective biomarker, and that's blood, urine, or breath ketones that can be measured with commercially available devices. And when your body's in a state of ketosis, that means that your metabolism has shifted away from glucose to fatty acid oxidation and ketone production and ketone metabolism, specifically in the brain and in the heart. And all your peripheral tissues. But the real function of ketosis is really to supply an uninterrupted fuel flow to your brain during periods of starvation or limited carbohydrate availability or just limited food availability. So that's kind of hardwired in us. We can all achieve ketosis, and there are many different ways to do that. And there are really profound therapeutic advantages to being in ketosis for specific applications.
So ketosis and ketogenesis is essentially a survivalist mechanism that evolved down through the eons. Ultimately, most people rely on glucose as a form of fuel, but this is a kind of a default fallback mechanism. Would that be right as far as fuel production is concerned?
Yeah, I would say that it's kind of unnatural for humans not to be in a state of ketosis, given that our early ancestors had limited food availability, limited carbohydrate availability, and the frequency of their meals were not anywhere near of, what the standard American has. So they had more metabolic flexibility, and humans have the incredible adaptability to eat pretty much anything, carbohydrates, proteins, and fats. And there are people who eat purely plant-based diets. There's people who eat only fruit, and there's people who eat only, meat and whale blubber, and they can thrive on these diets. So I'm an advocate of the ketogenic diet for specific therapeutic applications. I actually follow the diet myself, or a modified version of the diet. And I think there's a lot of advantages to doing so. But I don't try to push my nutritional beliefs on anyone. But I can just tell you from experience that some people thrive on it and some people find it very hard to stick to. And that's why, our lab is really focused on making the ketogenic diet easier to follow, inducing therapeutic ketosis with, exogenous ketone supplementation. And that could be an advantage for specific things that we study in our lab. And I think ketosis is a natural state. I think there's a question if ketones are the preferred source of energy for the brain, and that always comes up in conversations. And I think it is in specific contexts. And the body can use whatever fuels are available. And ketones are one of those fuels that should be available, through limited fuel availability, which was a natural state that we have essentially silenced in our modern everyday life.
Really interesting, because I spoke with a cardiologist last week who is a proponent of the Paleolithic approach. Basically, he ingests plants and whole foods, meat products, fish products, etc. He engages in intermittent fasting as well. So all of these things harken back to, as you mentioned, how our ancestors would have lived and existed and ingested. They would have gone hours without eating, and they would have had to rely on getting a fuel from whatever source they had access to.
Yeah, that's right. And depending upon their geographical location, the time of the year, whether they're near water, whether they're in the Arctic, whether they're in an equatorial region, that could be their diet could be incredibly diverse. And we have the ability to adapt to eating, that's why we are omnivores, But, even with people who ate a higher carbohydrate diet, they undoubtedly went through periods of limited food availability. So ketosis was even a natural state for people who, lived on a plant-based higher carbohydrate diet. So from my perspective, I got into this field of research because I was studying neuroprotective strategies, in particular to prevent seizures. And then also we gravitated to doing cancer research, and then neurometabolic diseases like inborn errors of metabolism, where many of the things that I just mentioned, especially inborn errors of metabolism, like different enzyme deficiencies or glucose transporter deficiencies, or just going back to epilepsy, drug refractory epilepsy, the ketogenic diet is the standard of care for those disorders when drugs fail. So that caught my interest, and I wanted to understand the mechanisms, the metabolic physiology. As a neuroscientist, I was very interested in the brain and how ketones could be neuroprotective and have anti-seizure effects. So over the last 15 years, that's been the cornerstone of my research.
There's a long history of research into this particular area, especially when it comes to epilepsy. I believe there were studies done decades ago on children, and they put them on a ketogenic diet or something equivalent to a ketogenic diet, and they noticed that a reduction in the number of seizures in those children. So there's a huge body of work here, and you're continuing that body of work now.
Yeah, 1920, Mayo Clinic sort of developed the ketogenic diet prior to the advent of anti-epileptic drugs. So it was really the only valid therapy for epilepsy and seizure disorders. And then drugs came on board in the 60s and 70s and largely replaced the ketogenic diet. And then in 1994, the Hollywood producer Jim Abrams was interviewed in the TV series, The Dateline NBC. So he talked about his experience with putting his son Charlie on the ketogenic diet after at least a half dozen different anti-epileptic drugs failed. And in his case, he was not really offered the diet, even though it was a standard of care, but he had to research it in the library, and he found out that this diet could potentially help his son. So he went to Johns Hopkins, and they were able to work with the team there, put his son on the ketogenic diet, and it rapidly stopped the seizures. So he became an advocate and actually became angry that this was not offered to him. And then that started the Charlie Foundation. The Charlie Foundation for Pediatric Epilepsy evolved to the Charlie Foundation for the use of the ketogenic diet for pediatric epilepsy and other disorders. So that includes like now a long list of emerging, different diseases, neurodegenerative diseases, cancer, a long list of different diseases are under investigation, with the ketogenic diet. But it took several, I think there's like 6 randomized controlled trials right now, I think, that have been done. And of course, there's many more in progress, but at least 6 RCTs that have been done with the ketogenic diet showing efficacy. So it's not like, it's not a fad diet. I study it as a valid medical therapy. For me, it's like, I think of the ketogenic diet as like a prescription strength diet. There's like internet keto, there's low carb. The ketogenic diet is a very precise macronutrient ratio that produces a profound physiological shift in brain energy metabolism that has anti-seizure neuroprotective effects. And I'm fascinated with, the underpinnings of how that occurs. And it's likely not one mechanism, but many mechanisms in synergy. And I think, there's so much research to be done. I feel like we're still in the nascent stages of really understanding what is the optimal ketogenic diet. I think there's genetics, personal differences in metabolism. I think there's a lot that we can do to optimize the ketogenic diet based upon the type of protein, the fatty acid composition, fiber, microbiome. There's so many different things. And then, of course, there's ways to further augment the therapeutic efficacy of the ketogenic diet with exogenous ketones. So that's another area. I think there's maybe over 100 clinical trials now registered on clinicaltrials.gov, just looking at, if you just type in ketone supplement. And, 5 years ago, there was nothing, or 5 or 6 years ago, I think the first, studies came out. So that's a huge explosion of research in a really, what was a very niche, esoteric area of science is rapidly expanding, and exciting to be part of that.
Can we look more deeply at that ratio of that ketogenic, the therapeutic ketogenic diet that you're talking about, as opposed to the internet ketogenic diet that many people, internet users, are probably familiar with? How do they differ as far as that ratio is concerned?
Yeah, I don't know. It just randomly popped into my head like internet keto, because I think what we're talking about, what a lot of people are talking about with keto is low carb. And I think there are tremendous benefits to being low carb. And that typically involves like just restricting carbohydrates to less than 50 grams per day may produce a mild state of ketosis. But the 4-to-1 ketogenic diet for someone like me would involve like 250 grams of fat per day, maybe about 80 grams of protein, and like essentially, 10 grams of carbs in the form of non-glycemic fiber. That's a very difficult diet to follow. And if you took 100 people and put them on the diet, for 2 weeks, I think 95% of them could not adhere to that. So it's a very, very strict diet to follow. I do think that more liberal forms of the ketogenic diet, one is coined the modified Atkins diet or modified ketogenic diet, which is like double the amount of protein. So upwards of 20 to even 25% of the diet being protein, as opposed to like 10%, of the calories. So the macronutrient ratios are such: a 4-to-1 ketogenic diet is 4 parts fat to 1 part protein, essentially, and like essentially no carbohydrates, for the clinical pediatric version of the ketogenic diet called the classical ketogenic diet, developed at Mayo Clinic. That was used for many years in pediatric epilepsy and still used today, but a lot of neurologists gravitate towards a more, especially with kids, because there was some evidence of it preventing stunting growth of kids with the lower protein content and stuff like that. Now we know a lot more about nutrition and about protein requirements. So it's important to, dietitians are aware of the potential side effects that could happen with the ketogenic diet. So more liberal forms of the ketogenic diet where the fatty acid composition incorporates medium chain fatty acids, and these can produce more ketones. So they are typically used in ketogenic diet formulations now.
What would you say to people who would push back against such a high ratio of fat in the diet? Now, you don't need to explain it to me necessarily, because I've spoken to many experts in recent months who've spoken glowingly about the consumption of fat and how we need fat, for example, to create hormones, etc. And we know that historically saturated fat has been vilified, and unfairly so. So could you explain your stance on fat and high proportions of fat in this particular therapeutic ketogenic diet that you're talking about?
The high fat is necessary along with, severe carbohydrate restriction, if you want to call it severe, and a moderate amount of protein. And what that does is it decreases the release of insulin, the postprandial release of insulin. So you have a continually suppressed hormone insulin, maybe slightly elevated glucagon, and this drives fatty acid oxidation in the liver, and that accelerated fat oxidation in the liver produces ketones. So that fat, the elevated fat, is really necessary in the context of a ketogenic diet to produce ketones. And, I've always thought that it can be a bit of a drawback because some people do have a fat intolerance. And there's also, in the world of cardiology, saturated fat has been demonized as being atherogenic. And that is, I would not argue with that in the context of like a normal standard American diet or Western diet. That saturated fat in the context of caloric surplus or processed foods, in that context, it has been shown to be atherogenic. And the jury's still out as to whether high saturated fat in the context of a clinical medical ketogenic diet or even a well-formulated low-carb diet is atherogenic. So one could point to LDL or ApoB and say that there's overwhelming amount of data to suggest that the high saturated fat, and some would just say high fat in general, is driving an elevation of LDL and ApoB. That apolipoprotein has been shown to be causative for atherogenic risk, especially in the context of elevated triglycerides and maybe elevated hemoglobin A1C. However, in the elevated ApoB and LDL in the context of very low triglycerides, high HDL, and other cardiometabolic biomarkers that are within what we would say optimal range, there's not data on that. And I would have to give credit to Dave Feldman and the Citizen Science Foundation that they're sort of spearheading research, which I think is very necessary, especially since there's a pushback to using the ketogenic diet for things outside of epilepsy where it could be therapeutic because of the perceived danger of elevated fat and elevated saturated fat in the diet causing an atherogenic risk through elevated LDL and ApoB. So I think we really do need to understand the risk of elevated LDL and ApoB in the context of other metabolic biomarkers that are essentially within excellent range, or even what some people would say optimal, like, low blood pressure, very low triglycerides, high HDL, low hemoglobin A1C, essentially like no inflammation. Like my HSCRP is like almost non-detectable, hemoglobin A1C like 3.9 to 4.1. However, my LDL is high, and my ApoB is on the high end of normal too. And I know I could bring that down if I just added carbohydrates to my diet, but my other biomarkers would also probably shift in an unfavorable direction. So there's just, and then there's pharmacological ways to lower ApoB and LDL. For me, there's a drug called ezetimibe, also brand name Zetia. So a very tiny dose of that will drastically reduce my ApoB and LDL because I presumably hyperabsorb cholesterol. So that is one thing that people can do if they're concerned with that. And then, of course, there's statin drugs, but they do have a risk associated with them, especially in higher dosages. So these are the things that are often talked about with ketogenic diets. And you mentioned, sorry to go off on a tangent, but the high fat is a subject of debate and unanswered research questions right now.
What I'm taking from that then is that if somebody was thinking of going on to a ketogenic diet, and I suppose when I say ketogenic diet, I'm thinking probably the internet keto that you referred to earlier, more that a lifestyle choice as opposed to a therapeutic requirement, that they needed to be cautious and have all of their markers constantly checked and monitored.
Yeah, I think that's correct because look, if you go on clinicaltrials.gov and just type in ketogenic diet, you're going to find about 400 registered, clinical trials. So I think we're going to have, 10 years ago, there was like 2 on there for like epilepsy. So there's a surge of research. Of course, some of it will probably yield positive results. Some may be neutral, some may be negative. Who knows? But the majority of studies coming out show a positive effect. And with ketone supplementation, the last I checked, there was 147 studies if you just type in ketone supplementation. So that is one way to kind of get around the super high fat, lower protein diet that's associated with the clinical ketogenic diet, is that you could follow a low carb Mediterranean diet, add, for example, medium chain fatty acids to that, which would elevate your ketone levels, or ketone beta hydroxybutyrate, which is a ketone body in the form of a ketone salt preparation or a ketone ester. So they're under investigation now. The ketone esters, I kind of shy away from. They do have applications. We studied that for military applications, but a ketone electrolyte salt like sodium, potassium, magnesium, calcium, that could elevate it up like in the millimolar concentrations. It also has the advantage of lowering glucose levels too. So I think, and like I said, I think there's a lot of potential for innovation in regards to the diet formulations and the supplementing the diet with ketogenic agents to mitigate, if it's a risk for some people, I think it could be if you have a history of heart disease in your family, hypercholesterolemia, maybe a low carb Mediterranean diet with ketone supplementation. If, for example, you're using the diet for the metabolic management of a neurological disorder, epilepsy or seizure disorder, something like that. So I think there's a lot of potential there. But in regard to biomarkers, so it's like blood pressure, fasting glucose, you could wear a continuous glucose monitor to look at postprandial glucose, super important, measure insulin, hemoglobin A1C, uric acid, high sensitivity C-reactive protein, vitamin B12 is also super important to measure, triglycerides, HDL, ApoB. Like these are all things that many of the things I mentioned there, about 80% of what I mentioned, maybe some may not be included in a CBC, comprehensive metabolic panel or CBC. So your standard blood work. So it's important that if you're going to follow the ketogenic diet to get a baseline, everybody should get routine annual blood work, but I've seen some pretty profound changes in blood work and people actually liver enzymes elevated. Yeah, it's like maybe 10%. Some people have an elevation of liver enzymes, but these are like important things to check if you're going to follow a diet and it's, quite extreme relative to what you're already following.
The liver enzyme increasing as a result of the fat intake, would that be correct?
It can be. Usually, I'm of the opinion that low carb diets and ketogenic diets are almost a way to cure non-alcoholic fatty liver disease. Because I've seen it. So I did not know this, but we had an interventional radiologist who was really not a fan, I don't think, initially of low carb diets or ketogenic diets, but he reached out to me and was like, I tried putting my patients on everything. One of the patients, some of my patients were adamant about doing this keto thing, he said, and then we did scans and their non-alcoholic fatty liver kind of went away. And that was about 10 years ago. And then that was very interesting to me. And then I've got a lot of anecdotal reports, and now you see it in the literature, low carb diets tend to get the liver to metabolize fats, clear fatty deposits from the liver. Essentially, I think what's happening too is that low carb diets and ketogenic diets inadvertently produce caloric restriction. It's hard to like overconsume if you're not eating hyperpalatable food. I always say like the ketogenic diet tends to be hypopalatable and hypersatiating. So for me, it's very indulgent, and I really enjoy eating a ketogenic meal, low carb meals, things that I went many years avoiding, like egg yolks. I always just threw all my egg yolks away and had egg white omelets and oatmeal for breakfast. But gravitating to a ketogenic approach, you're full, you're satiated, and I think the the mechanisms that control eating behavior are kind of restored in a way that prevents you from overeating. So when you do that and your calorie output matches your input, or there's a slight deficit, if you're eating any diet, that could often cure non-alcoholic fatty liver disease, unless you're eating like massive amounts of fructose or something like that, which tends to sort of increase de novo fatty synthesis in the liver. So I'm of the opinion that, non-alcoholic, you mentioned liver enzymes. Yes, I have seen in people that have jumped to a ketogenic diet that have been weight stable, see an initial elevation of liver enzymes, but they usually go back down to normal. And the liver does have to work a little bit harder, like initially when you start ketogenic diet, because it's quite a heavier fat load, than most people are eating. But in many ways, it kind of can restore. I mean, I've seen people go on a ketogenic diet. I mean, conversely, where their liver enzymes are elevated, especially ALT, and then it gets cut in half after about, in our study, I've seen it go down like in half in 12 weeks. So, which is normal actually, but it's something that people have to track because we are all like unique metabolic entity, and our responses to different diets and the foods within those diets can vary tremendously. So that's why I am a really big fan of N of 1 research and actually tracking metabolic biomarkers, and then wearing like things like continuous glucose monitors, and then having routine measurements of cardiometabolic biomarkers that are above and beyond the standard CBC comprehensive metabolic panel, and that's, just about a half dozen different things that I mentioned, just to tack on would be, you could typically talk your doctor into adding like ApoB or insulin or hemoglobin A1C, HSCRP. Like I was able to talk my doctor into doing that before. So just like a little heads up for people out there listening, that if you talk to your doctor and let them know that you're educated and you're concerned about this, and you have, a risk of cardiovascular risk in your family, they can usually add it and insurance covers it, at least in the US. So.
You mentioned it there just while it's in my mind. You were talking about the liver, non-alcoholic fatty liver disease, and fructose, which would lead me to the question, you probably always ask this, but I'd love to hear your response. Fruit. What are you ingesting as far as fruit is concerned? I'm guessing not very much on your particular version of this ketogenic diet.
Well, I'm actually a big advocate of including fruit, but the fruit that I have, are I avoid things like bananas, or I was going to say I avoid mangoes, but we have a mango tree. And I actually had a mango last night, and what I do is I eat it when it's slightly firm and tart, instead of mushy and super sweet, right? So I have buckets of mangoes now, and I tend to eat them when they're kind of crunchy and tart. Apples, but I think the things that I stick to routinely are wild blueberries and maybe like green apples here and there. I have blueberries every day and apple here and there. And I don't see any, after dinner or something. That's really like my only carbs that I have. And it's high fiber, it's low glycemic index. Apples have something called like pectin in it, which is a type of fiber you don't, fully break down and absorb. So I am a fan of fruit within reason. Fruit has fiber with it, whereas fruit juices, high fructose corn syrup, and fructose sweetened beverages are on the far end of the spectrum of being almost borderline metabolic toxins. So, because if you drink a fructose sweetened beverage or a sugar sweetened beverage, you get a bolus of sugar into your system, and sugar is toxic. And your body, a normal healthy person can deal with it, but most people, at least in the US above 50, are not healthy people. So when they're doing that, these postprandial excursions in glucose are, they induce inflammation, they induce clotting, your blood becomes more, viscous however, if you're a healthy athlete in high school or 20s or 30s and you work out, I mean, sugar is probably fine, but you don't know unless you're not, if you're not monitoring and tracking these things, you won't know. Actually, that's why I think continuous glucose monitors are very boring if you're on a low carb ketogenic diet, because it's just a flat line. But if you're an athlete trying to optimize your carbohydrate consumption to as high as possible for glycogen replenishment or performance, then a CGM is actually probably favorable in that context, if you choose to be a carbohydrate fueled athlete. So, but I think there are advantages to being a low carb ketogenic athlete in regard to metabolic flexibility and being able to have access to fat as a fuel source with low insulin, and you have greater sort of access to fat, especially in the context of long duration endurance events.
I want to come back to that actually, because I read a paper that you co-authored with Dr. Timothy Noakes on that very subject. But if I can come back to that a little bit later on, I want to just broach the subject of cancer. I spoke with a fascinating woman a few months ago on this podcast who had been given a terminal diagnosis of brain cancer. It had spread elsewhere in her body. She was given 6 months to live. Immediately, she turned her diet around. She went on a very strict ketogenic diet, and 6 years later, she's still alive. And I know that she has been in communication with Professor Thomas Seyfried, and she's become a campaigner for this diet, especially for cancer patients. I want to hear your thoughts on a ketogenic diet and its ability to help people clinically with cancer, for example.
Yeah, I got interested in ketogenic diets for brain cancer specifically. The standard of care for glioblastoma is it really doesn't exist. I mean, it kind of leads to the demise of the patient. It doesn't really extend survivability. So that was the low-hanging fruit in regards to studying cancer with a ketogenic diet. And theoretically, it made so much sense. I didn't really see myself going down the path of researching cancer, but we made some observations in our lab with hyperbaric oxygen effects on just cancer cells in a petri dish. And then ultimately we moved that to an animal model of metastatic cancer, which actually was derived from Thomas Seyfried and actually made the cover of International Journal of Cancer. It's a great model of metastatic cancer. And, so we validated some of the results that he saw on the growth and the spread of metastatic cancer and the increase in survival in the animal model with cancer. So you do become a believer when you run these studies and you see, animals quickly dying on a standard diet, and then, all the animals in the ketogenic diet, for example, are still alive. That does have an impact on your thinking when you see that, whether that's biased or not, right? Because we're just talking about an animal model. But soon after doing this research and publishing this, then people look at the research and then they extrapolate it to humans. And there was some case reports in pediatric cancers, on pediatric brain cancers, and kids using it that were encouraging. And then I started getting feedback from cancer patients using it, not only for brain cancers, but for different types of cancers, and getting remarkable results. So we believe that a ketogenic therapy can enhance the standard of care, that's chemotherapy, radiation, and also immune therapies. However, we also believe maybe in certain contexts that ketogenic diet and a comprehensive metabolic-based therapy that includes different off-label drugs, I mean, simple things like metformin, to a whole list of other different types of supplements and drugs that, we're studying could be combined in a comprehensive metabolic-based therapy that could likely outperform existing standard of care therapies, which that's easy to do because they're not very efficacious anyway, or things like glioblastoma. So a big part of what we do in the lab is actually looking at, different types of diets, we've studied everything from metformin to 2-deoxyglucose to clonidamine to sodium phenylbutyrate, that could help lower glutamine levels. Right now, we're actually looking at allulose, D-allulose, which is an epimer of fructose. So it looks identical to fructose, but it gets transported through the GLUT5 transporter. And when you try to grow cancer cells with allulose, when you grow certain cancer cells that overexpress the GLUT5, they will grow very quick and they'll proliferate very rapidly and when you grow them with fructose. And if you give allulose instead of fructose, then that basically stops their growth and they die. So, and fructose is something, it's a sweetener, so we have a natural, some people think it's an artificial sweetener, but it's actually a natural sugar that's found in things like figs and kiwis, I think. And you can consume it as a sugar, as a sweetener, and it's potentially, has anti-cancer effects. So we think that there's a real potential here to sort of engineer a low-carb diet or ketogenic diet that has functional ingredients that could not only improve ketogenesis and lower blood glucose and insulin and improve other cardiometabolic biomarkers, but also target metabolically the growth and proliferation of cancer with specific food ingredients. And I think there's a lot of room for innovation there, and we're really motivated, although it's hard to get funding for this kind of research. So we have little pet projects. Some of them work out, some of them don't, but the ones that work out, we try to move that into like a different animal model. So we can validate, cell models into animal models and then move that to human clinical research.
When I had Professor Seyfried on the podcast, he was at pains to say that he believed that cancer was a disease of mitochondrial dysfunction as opposed to genetic abnormality. Would you go along with this particular thesis? And then what role then would a ketogenic diet play in that model?
Yeah, I get asked this question a lot. I think cancer is a metabolic, epigenetic, and genetic disease. So I don't want to sound like a centrist or whatever, like somebody in the middle, but metabolism drives the metabolic state of a cell, or in biochemistry terms, the bioenergetic state of the cell, the level of energy that the cell has, will dictate the fidelity of the nuclear genome. So, and things like DNA repair and the production of proteins and enzymes and just cellular processes in general. If that metabolic state of the cell, the bioenergetic state, gets compromised, then DNA repair does not happen in a robust sense at the level of the nucleus. And the mitochondria have less capacity for DNA repair. So if the mitochondria become compromised, and there are many different things that could compromise mitochondrial function, from toxins in the environment to inflammation to high glucose to, many different things. Once metabolism becomes compromised, then the cell is more likely to accumulate genetic defects. And those genetic defects, once they accumulate, they can cause a normal cell to transition to a cancer cell. And then there becomes, once the cell, divides and mutates, there's a point of no return where you have an oncogenic transformation. And then that cell, if it's seeded in the right environment and it becomes metastatic, for example, for example, like you have colon polyps that develop and then spread to the liver, then the liver is kind of like a very fertile ground for that to spread and grow. Then that could be problematic. That's why keeping the liver healthy is probably one of the most important things that we could do for our metabolic health, but also preventing things like cancer, because that's sort of the detoxification organ. And sorry to go off on a tangent again, but I think that metabolic health is the cornerstone for preventing cancer. So stated another way, healthy mitochondria are the ultimate tumor suppressor, right? So if we have really robust functioning healthy mitochondria, it's going to be far more unlikely that that you're going to have the oncogenic transformation of a normal cell to a cancer cell if the mitochondria is robust and healthy, because you're going to have normal DNA repair, normal processes. But some people do have mutations, and some people are exposed to environmental toxins, and some people, hey, you got, people that are healthy athletes, Lance Armstrong, maybe. Maybe he used some performance enhancing, and maybe there's certain drugs and growth hormones and things like that that can promote cancer. But we see it's much more rare, but normal healthy people, for example, getting brain tumors, getting leukemias, lymphomas, things like that. And I know a few of these people, and it is, so that becomes a point of contention to justify that cancer is purely a metabolic disease when you have someone who has really great metabolic biomarkers get diagnosed with cancer. So that, however, we do know that cancer is also a disease of aging, and as our mitochondrial and metabolic health decline, then we are far, far more likely. So there's a whole bunch of different diseases that are pathophysiologically linked to metabolic dysregulation. And the cancers like colon cancer, pancreatic cancer, gallbladder cancer, liver cancer, all these things we're far more likely to get if we if we're obese, we have type 2 diabetes, and we have poor metabolic health. So that's like probably one of the most important messages here.
Do you engage at all in intermittent fasting or time restricted eating in conjunction with your ketogenic diet?
I do, but it becomes not the default, but something I do periodically. So I did for many years actually do intermittent fasting. I would come to work, I'd lecture, I'd have meetings, and then I would eat like my first meal at 12 o'clock or 1 p.m. And then I did that for a couple of years while staying ketogenic, and I started losing, my DEXA scans showed that I was losing lean body mass over the years. So I became, especially now that just about 50 years old, I become much more cognizant and aware of, maintaining body composition, strength, and muscle as I age, because it becomes harder, especially when you get into your 40s and towards 50, into your 50s, to maintain that. So I think intermittent fasting is great to create a calorie deficit. And if your protein is sufficient and you can spread that out over 2 or 3 meals with intermittent fasting, then I think it's totally fine. But then again, like some people, when we talk about it, it's like either you do it all the time or you don't do it. But for me, like I'll do it like once or twice a week, because I do feel more alert and more energetic actually if I'm in a fasted state, especially throughout the morning.
And of course, it echoes what we started off this conversation talking about. It echoes exactly what our ancestors probably would have had to endure, in that they wouldn't have had their 3 square meals a day. So they would have gone many hours probably without a meal at one point. And speaking of which, can we talk just briefly about the carnivore approach? I had Dr. Ken Berry, who is a big proponent of the carnivore diet, on the podcast a couple of weeks ago. And he preaches from the rooftops about the carnivore diet. I just want to get your opinion on the therapeutic benefits of something like the carnivore diet, or if there are indeed research results out there showing that the carnivore is something that would be good for somebody with a chronic disease, etc.
Yeah, well, I'll start with the research first. I think the research is pretty limited. And I do know that there's a researcher professor at Harvard Medical School, I think Belinda Leonards, is doing sort of a study looking at hundreds of people following a carnivore diet, specifically looking at like cardiometabolic biomarkers to see if it's healthy. And people are following carnivore diets for different reasons, right? So the preliminary research, I don't think it's published yet. I just saw it in like a conference presentation, but I think it probably will be published pretty soon, that there are no, at least if you look at the blood work, no overt side effects from following a carnivore diet for a few years. So I'm not sure of the total duration, but these were like more or less long-term carnivore advocates and followers. So a carnivore diet is a low-carb diet, obviously, and can be ketogenic if the cuts of meat are fatty, right? And it's like you don't have surplus amount of calories. There's a group in Budapest, Hungary that have been advocating for a paleo sort of ketogenic approach, and their diet is just a meat-only diet. Paleo Medicina is the name of the group, and we visited Budapest, Hungary, and went to their clinic, and they pulled their files out and showed me a number of case reports that were very compelling. So, and they really had nothing to hide. They were just showing me blood work, before and after. And that was the first time I actually saw research, and they've published about a half a dozen different publications, case reports, and things like that. They're not doing randomized controlled trials, but I am not I guess what you would call, there's these RCT fundamentalists who are like, they don't believe anything unless, there are several RCTs, but we have to realize that randomized controlled trials are primarily funded by the pharmaceutical company. Drugs are great. They have their place, but you're not going to find, like I mentioned, there are about a half dozen RCTs with ketogenic diets, but that took a monumental effort to pull that off for epilepsy. So you're not going to find, anytime soon. They might be in process, or some people may be, privately funding this, or a foundation will have to step up and fund like an RCT on a carnivore diet. But I do think that it can be it's an elimination diet. And I've gotten enough emails in my inbox, hundreds over the years, to suggest that it's therapeutic. So I do think there's a place for it if you can stick to it and you closely follow cardiometabolic biomarkers. And if you see no overt changes in atherogenic risk, and you see things going in the right direction, and most importantly, you feel good, and your body composition changes favorably, I'm an advocate for it.
I just wanted to get your thoughts on that because there seems to be an awful lot of interest in it at the moment. We mentioned this earlier. You co-authored a really interesting paper with Dr. Timothy Noakes that looked at athletes consuming a low-carb, high-fat diet, and you made some very, very interesting observations about their fuel source during low-intensity versus high-intensity exercises. Could you talk to me just briefly about this?
Yeah. Well, there's a couple papers we published also published on the crossover point too. But I think the one publication that I recently presented in Switzerland was putting a group of participants, pretty elite level athletes, cyclists that were on a high carb, low fat diet and a low carb, high fat diet. And it was a crossover design with a relatively short washout period. But essentially it showed that, and these were not like low carb athletes to begin with, right? So they were just following like a mixed diet. It showed that in the context of performance, that there was no difference in performance, cycling performance, right? We're not talking about super long endurance, but there was another question that we wanted to answer, that you could do repeated bouts of higher intensity, like shorter duration cycling, and do multiple sort of sets of that. And surprisingly, I think the hypothesis was, Jeff Volek was on this too, that we would see a decrement in performance with repeated bouts of cycling that were done consecutively over time, in relatively shorter bouts, just a few minutes. And we did not see a decrement in performance of high carb versus low carb. But what we did see in regards to the biomarker tracking was that we did see an elevation of LDL. So with low carb, high fat diets that had been seen before. But from my perspective, some of the most interesting results that came out of that study was that the high carb group, again, these were pretty advanced athletes. The high carb group, if we looked at the circadian glucose over time, because they were wearing continuous glucose monitors, there was 3 subjects, and it was just 10 participants per each group. There was 3 subjects that were basically pre-diabetic following the high carb, low fat. And these were like elite level athletes. And we would have never guessed that, especially if we looked at, if we further dived into that data and looked at their nighttime glucose over the course of the 8 hours that they were sleeping, like it was on the order of like 20 to like 30% higher. So you could pull the paper, it's open access, and look at that. But on average, the high carb, low fat group had significantly elevated glucose even throughout the course of the day, but especially at nighttime. And then there was a subset of that group, 3 participants, 30% technically, that had pre-diabetic levels of glycemia. And that really kind of surprised us. So we're thinking like, the average athlete or person that calls himself an athlete that just like cycles on the weekend and that has relatively just modest metabolic health, if they were following this high carb approach and they had those glucose levels over a protracted time frame, that would be damaging and atherogenic, because we were not, it was just like the standard high carb, low fat diet that was advocated for in all of endurance activity. It wasn't like overboard, and it was calorie matched too. I forgot to mention that it was isocaloric. It was calorie matched. Now, so there was some people that criticized the study because the protein content of the high fat, low carb diet was a bit higher. So it was like, 20, maybe 4% or 5% relative to like 18% for the low fat, high carb group. But that level of protein, like statistically, shouldn't make that much of a difference. And also the low fat, high carb group was basically using the diet that was reported to be optimal for athletes who do follow a high carb, low fat diet approach. So elevating protein in that context would be sort of steering away from what's optimal for the high carb athlete. So all things considered, there's no advantage to high carb relative to low carb, even with repeated bouts of intense exercise performance. And biomarkers, that is to be debated. Elevated LDL, it's the jury's still out whether that's an atherogenic risk. But the glycemia was definitely higher with the low fat, high carb group, and to the level that would be concerning for most, even endocrinologists. So that was like, that's an unbiased overview. I could have pitched it and described it a little more, more of a proponent to the high fat, low carb group. But I think it's remarkable that you could achieve the same performance. And I think many people who look at that study, that will be the take-home message. But for me, I think the take-home message is that you could be a great athlete and follow a high-carb diet as a great athlete, and still your glucose could not be managed from a circadian perspective if you're wearing a CGM. It's in the level of pre-diabetic, and that's concerning.
Yeah, and it's really interesting as well because I'm an amateur triathlete myself. And I'm always wondering about consuming too many carbs during a swim or run or a cycle. And so that's really interesting. I presume this study needs to be replicated over and over in order to really verify the results that you found, because you said the numbers involved in that study were actually quite small. Would that be the case?
Yeah, they were relatively small, but the study design kind of compensated for that. And it was very well controlled. I mean, from matching calories to, the crossover design with a washout period. What I would do in hindsight is just to have like a mixed diet that's sort of not as high, like a moderate protein, moderate carb, moderate fat diet. And I think, that would probably be, I think you would get equal performance and also favorable, biomarkers in response to that. And I think that's a lot of athletes are trending to that and kind of getting away from just bolusing Gatorade and all the gels and things like that. They're gravitating more towards like a mixed diet. But the high carb, low fat diet was basically, the protocol, and the macronutrient composition and calorie load that would be typical for an endurance athlete. So kind of stuck with that. And then the low carb, high fat diet was sort of similar to what Jeff Volek had advocated for. And there was there was slightly higher protein in that group just because of the palatability to make that low carb diet palatable, right? So if you're like, 10 to 15% protein and you're trying to get in 80% fat, most people have a hard time consuming. They'll get nauseous with that amount of fat. So you just bump up the protein slightly just to make it, palatable and consumable.
Really interesting stuff. If people want to find out more about that article and want to find out more about your work, where can they go online?
I want to mention that the senior author of that was Philip Prinz at Grove College. He was the first author, and the senior author was Dr. Andrew Kutnick, who did his PhD in my lab looking at cancer cachexia. He was a senior author, and then Jeff Volek, and as you mentioned, Dr. Noakes was on it too. So yeah, go to PubMed and you can just do, my name, D'Agostino, DP, and then look at our publications. And KetoNutrition.org is the website that we have. And we have a blog that hits on many topics that we just talked about. So I have a breakdown of, everything that you can think of in terms of metabolism. And also like to mention the Metabolic Link podcast, which we have. It's sort of a companion to the Metabolic Health Summit, which we've been hosting for several years now, which has upwards of like 800 people, attendees. Then we have an online platform that's also ACCME accredited. It's like the highest level of medical education as part of the Metabolic Health Initiative. So Metabolic Health Summit, Metabolic Link podcast, and KetoNutrition.org website. So those things there will give you a lot of information about, things I've talked about.
I'll link all of those in the show notes of this episode. Dr. Dominic D'Agostino, thank you so much. A real pleasure having you on the podcast today. Thanks for your time.
Appreciate being on. Thank you for having me.
Well, thank you for tuning into this episode of the Happy Habit podcast. If you enjoyed it and would like to show your support, it's free. You can like, subscribe, and tell other people all about this podcast. Until next time, stay happy. Thank you.